Okay, so I'm just seeing whether or not we've got this microphone working. All right, are you getting anything from it? Okay, I'm walking to a different room. Are you getting anything now? Okay, so I'm moving around on my shirt here. Is this a little bit better? Okay, so I've got it a little bit down on my shirt, but that seems to be doing okay for sound. All right, that'll work. Thanks. Hi, everybody. Sign in if you would. Let me know who's here. Good morning. Good morning. Sign in if you would. Good morning. Good morning. Can you hear me pretty well? Give me a thumbs up if you can hear me. Welcome aboard, everybody. All 5 of you. All right, I'm betting that the sound sounds a little bit better today than even yesterday. Does it have the echo like it did yesterday? Okay, that's because I've got this is part of me becoming a YouTube star. So I now have a remote microphone that should take care of some of that. So hopefully it is sounding better. If it's actually to a point where you have to turn down your sound, that's awesome. So, all right, at this point in time, we've got 6 people in the room. Let's go ahead and take a look at whatever problems that we want to take a look at off that review. We'll do some general questions and some things on that as well. So go ahead and post a question. I'm going to run and grab the test just so I can kind of give you an idea of what's going to be on it on Monday. I'll be right back. So I am back. All right. Okay, so the first thing that I see is going over the quiz. Now, I believe everybody that's in the room, you have actually taken the quiz. The one thing is we still have a few stragglers on that. So again, I'm going to ask if you're on or not to make sure, that we don't send that out to somebody else. Okay, I just got going up the stairs, so that's why I'm breathing a little hard if you hear that. Okay, Epaso, is there one particular question in particular that you are considering on the quiz? I don't have it directly in front of me here. Let's see if I can pull that up real quick. Okay. All right, so again, everybody can hear me well. All right, so I'm just kind of readjusting my page here so that I can see the quiz, but yet still kind of be looking at the room here a little bit. Okay. All right, so we're going to start with the quiz here real quick. So we're looking at the third question that was on the quiz. Okay, so starting with the quiz here, we have the following. So it says find the exact solutions on the interval from 0 to 2 pi. Okay. So in this problem, we are looking at doing 2 times the cosine of 2t plus the sine of 2t times the cosine of 2t minus the sine of 2t, and that's equal to negative 1. Okay. All right, so I'm going to minimize this screen here for just a second so that I can see most of my board here. All right, so in this particular case, for this particular problem, the first thing, we got a couple of different things that people did. We did have some people that divided by 2 and just got it out of the way right away, which is perfectly fine. And then we had others that multiplied these together, which we should recognize as a difference of perfect squares. And that was the intent of this one. So I'm going to do these two things at once. So I'm going to multiply the binomials together. And then I'm going to divide by 2 at the same time. So when I do cosine of 2t plus sine of 2t times cosine of 2t minus sine of 2t, that's going to give me the following. That will give me cosine squared of 2t minus sine squared of 2t, and then division by 2 would give me negative 1/2. Now, from here, what we would want to recognize that cosine squared minus sine squared is a double angle identity, and it would be the double angle identity of cosine. Now, we have to keep in mind that my angle is already doubled once, so when I use the double angle formula, I'm actually going to be doubling, not t, you're doubling 2t. So this would become cosine of 4t is equal to negative 1/2. Now, what this 4 is essentially telling us is that we're going to have 4 times as many answers as if it was just t. Now, here's how that works. We have to keep in mind that 4t is the angle. So I'm looking for the cosine of the angle, that's 1/2 as a negative. So on the unit circle, when I consider those positions, cosine is negative in quadrant 2 and in quadrant 3, and so that will happen at 2 pi over 3 and at 4 pi over 3. Okay? So from here, what that's telling us is that the angle would be equal to 2 pi over 3, but I have to add my repetition here. I always need to consider that. And in this case, it's going to be a repetition of 2n pi because these are not evenly spaced around the unit circle. So it would be 2 pi over 3 plus 2n pi. I would make that same argument for the other one as well. So I'll cover that one in just a second. But now, again, what I need to keep in mind here is I need to get the t by itself. So what's going to happen is that my increment of 2n pi is actually going to become smaller, as is my original value that I found. I'm going to multiply everything by 1/4. And I'll reduce as I go here. So what this is going to tell us is that t is equal to, in this case, I can reduce the 2 and the 4 for a 2 on the bottom. So that would give me pi over 6. And then the 2 and the 4 reduce here to give me n pi over 2. Now, because these are different denominators here, what I'm going to consider on that is that to make it easier for me, a little bit more efficient, I know that I'm going to have to multiply by 3 over 3 here. So that's going to make this not an n pi over 2, but a 3n pi over 6. So now when I go to find my values, my actual values here, my first one I'm letting n equals 0, which is just the pi over 6. but then I'm going to let n equal 1. So now I'm going to have 3 pi over 6 plus pi over 6, which would be 4 pi over 6. But then keep in mind that that can be reduced by 2, so it would actually be 2 pi over 3. Now I'm going to let n equal 2. Okay, so 3 times 2 is 6, so it'd be pi. So I've got 6 pi over 6 plus pi over 6. That would be 7 pi over 6. And then finally, let's go the next one. We're at 3 times 2, so 3 times 3, that's 9 pi over 6 plus pi over 6 would be 10 pi over 6. But again, that will be another one that then reduces to the 5 pi over 3. Okay, so we're getting 4 answers from the first one. And now the same thing will happen when I change from 2 pi over 3 to the 4 pi over 3. So I'm just going to, so if you're okay here, I'm going to go ahead and change this to the 4 pi over 3. Okay, so I'm looking at my next one. So that's going to change this result down here to now just be pi over 3. This will stay the same because the increment still started as 2n pi. Dividing it by 4 made it pi over 2, keeping it 3 pi over 6, although instead in this case, if I leave this as an n pi over 2, the issue that we're going to have here is now we got a common denominator for both of them, and that's okay. We can do this, so I might just have to do a little bit of math with it, okay? So keep in mind that our first increment out of the second one of these, okay, so now taking this one, I'm going to have pi over 3 to begin with. Okay, again, that's when n is equal to 0. But now, just to try to make it a little bit more efficient, I want to be thinking about it this way. So I'm going to multiply by 2 over 2, 3 over 3. So I'm really looking at 2 pi over 6 plus 3n pi over 6. And then I'll just reduce things as I go. So again, letting n equal 0, this drops out. 2 pi over 6 gives us the pi over 3. Let's let n equal 1. 3 pi over 6 plus 2 pi over 6, that will be 5 pi over 6. Okay. 3 times 2 is 6. 6 pi over 6 plus 2 pi over 6 is 8 pi over 6, but that reduces to the 4 pi over 3. All right. Then we're going to do it again. Multiply times 3. 3 times 3 is 9. 9 pi over 6 plus 2 pi over 6 is 11 pi over 6. And there would be then your 4 other answers. Okay, so something to keep in mind on these is that, like in this case, when I come back up here, if I see a number here, okay, 4, 3, whatever this number is going to tell me how many times more answers I have than from the original angle. Okay, so take a look. Cosine of 4t is equal to 1/2. If it was just cosine of t equals negative 1/2, if that was all we had, then we would just have these two answers and that would be it. But because the 4 is there, what this is telling me is that I'm going to have 4 times as many answers as what I had from here. 2 answers here. 1, 2, 3, 4, 5, 6, 7, 8 answers there. So this is giving us an indicator as to how many answers we should have. All right, so there's problem number 3 from the quiz. I'm assuming that everybody's in this room has taken this. Okay, otherwise you would be invalidating the quiz. That would be a little unfair to the others. Hopefully that's not anybody doing that here. Also, be sure, everybody, that we have some people who haven't gotten some things in. If you would do me a favor, is to make sure if you're connected with them via text, media, whatever the case may be, please remind them to get their stuff done, because we are moving, and there's not going to be anybody that's going to get till April 6th on this stuff. We are starting. So, all right. So from there, I'm seeing number 51 on the review, the tangent part. Okay, so I'm looking at yours. Okay, so in this case, notice it's saying use the sum and difference formulas. Now, I'm going to address this in two different ways. Okay, so in 51, they're saying 285 degrees is equal to 315 degrees minus 30 degrees. Okay, now keep in mind there's two different ways that you can do this. Is that since you had to find the sine, you essentially had to find the sine of what would be 315 minus 30, and the cosine as separate results here, you could essentially use this particular process to get your tangent value. Okay, so this is one way to do it. If you could let me know, did you try to use tangent formula, or did you use the sine over cosine? If you can type tangent or type sine over cosine, let me know which one. I'll try to honor what you've tried. Okay, so you tried the tangent formula. Okay, so what I have to keep in mind is then I'm doing the tangent of the subtraction. Okay, so essentially they're saying the tangent of 285 is going to be equal to the tangent of 315 degrees minus 30 degrees. All right, so in that case, I believe we would have tangent of 315 degrees minus the tangent of 30 degrees, all divided by 1 plus the tangent of 315 degrees times the tangent of 30 degrees. So what this is going to require then, and again, I'm hoping that this is where you started, but then what we'd have to do is we have to calculate the individual tangent values for 315 degrees and 330 degrees. So let's see if we're on there. Okay, so I got to be thinking tangent sine over cosine here. So the tangent of 315 degrees, I'm essentially doing the sine of 315 divided by the cosine of 315 degrees. All right, so in this case, we should be finding that the sine and cosine values are the same numbers except just opposite in sign. The sine value itself would be negative radical 2 over 2. The cosine value would be radical 2 over 2. And so we'd be doing a negative divided by a positive or a negative, which would give us just 1. Okay, so that takes care of the tangent 315. So wherever those are at, I can put not a 1, but a negative 1. Okay, so I'm going to be able to replace in my formula now for everywhere that there is a tangent 315, I can now place a negative 1. Okay, then from here, now I've got to go back and do the same thing with the tangent of 30 degrees. So again, writing this, I'm thinking sine over cosine. The sine of 30 degrees is 1/2. The cosine of 30 degrees, radical 3 over 2. So in this case, because of the fact that the denominators are the same, I can reduce those, and it leaves me with 1 over radical 3. Okay. Now, let me check what they're doing in the answer here, whether or not they are, if they're doing something more with the answer. I don't know if they're having you do more with it. So give me just a second here. I'm going to take a look at the key here, and we're looking at 51. Okay, so they're manipulating the final result a little bit. Okay, so what they're going to do here, I'm going to go ahead and rationalize this. So that's just going to be radical 3 over 3. So in my formula then, I would have then negative 1 from the tangent of 315 minus radical 3 over 3. And then in the bottom, 1 plus negative 1 times that radical 3 over 3. Okay? So where they're going to go from here in just cleaning this up. Now I'm running out of room on my board here. So if you're okay with this, I'm going to erase that, and I'm going to start doing my work over there. So the first thing I should notice is that in the bottom here, just to save a little bit of space, is I know that this is just going to be 1 minus radical 3 over 3. And then in the top, the negative 1 minus the radical 3 over 3. So just getting it all into the same color here. So now what I've got to do here to try to get to the form that they're getting to, I think I'm going to play with the individual numerator and denominator here and get them all to a common. All right, so again, trying to save a little space, I'm going to multiply this one by 3 over 3. I'm going to multiply here by 3 over 3. So what that would allow me to say then is the following. I'd be able to say common denominator here. I can say negative 3 minus radical 3 all over 3. That's from the numerator. The denominator, I would get essentially pretty close to the same thing. It will be 3 minus radical 3 all over 3. Now, what's going to make this clean up quickly again is notice both denominators are 3. So I can reduce those out. Now that's giving me negative 3 minus radical 3 over a positive 3 minus radical 3. So where they're going to take it from here is they're going to rationalize that denominator. So this is one of those particular cases where what we need to use is a conjugate. Okay, so again, keep in mind a conjugate is what would set up a difference of perfect squares. So I have 3 minus radical 3. I'm essentially going to multiply the denominator and the numerator by its conjugate, which would be 3 plus radical 3. Now, what this does is it sets up our denominator as a difference of perfect squares so that when I clean it up, I'm no longer going to have a root because I'm going to be getting 3 squared, which is 9. That's coming from here. But then I'm doing radical 3 times radical 3, which is just radical 9 or 3 itself, but it would be 9 minus 3. Okay? Then from here, in the numerator, I'm going to have to go ahead and multiply that out. Now, in this particular case, it's not going to be quite as nice, so I'm going to go ahead and multiply it again. I'm going to try to save some space. I'm just going to do this mentally here. So first, I'm going to get a negative 9. Now, take a look at your inside and your outside here. Okay, so again, I'm using a FOIL method here to save space. Negative 3 radical 3 and another negative 3 radical 3. That will be negative 6 radical 3. Okay, so I got 2 of those. and then negative radical 3 times a positive radical 3 will be just a negative 3. Now we got to be careful here. Negative times a positive makes it a negative. 3 and 3, square root of 9. So notice from here, now I can clean some things up. Negative 9 minus 3 is negative 12 minus a 6 radical 3. The denominator 9 minus 3 being 6. So what they're going to do from here is now they're going to just start cleaning this up a little bit. Now, so what they're going to do is they're playing with some things here. I could reduce by 6. Now again, if I made a mistake, please make sure you let me know, because I'm just as human as all of you. You just can't stop me as easy. I've got to be watching the kind of the side feed here. I'm going to reduce by 6 here. So I'm going to reduce by 6. That's going to give me negative 2 minus a radical 3 altogether. So I'm not sure where, oh, I'm looking at the wrong one. There it is. Okay. I was looking at the sign. I'm sorry. So there would be our final result then. Okay. Does that make sense? Give me a thumbs up on that if that makes sense. Okay. Now, this would be another one of those types of problems, and this goes to everybody, is that since you're being asked to calculate all three, where you'd have to find the sine and the cosine, you may find that it is actually more efficient to just take the sine value and divide by the cosine value. I mean, look at all the work that we had to do to get the tangent value. Okay? Now, just to show you real quick, had I used my sine and cosine values, and again, you could use them from different positions, most cases where you don't do any rationalizing of a denominator, at least to begin with, but the sine value is the following. So if I follow sine over cosine, they're saying it's negative radical 2 over 4 times radical 3 plus 1. The cosine value is a radical 2 over 4 and then a radical 3 minus 1. Okay, so this is your alternative method. And to be honest with you, I think this one's a little bit more efficient, because look at where we're at already. Negative radical 2 over 4, radical 2 over 4. We're going to reduce those. We just can't lose the negative here. Okay, so we can't lose the negative here. But notice then at this point in time, I'm already to the point where I can just rationalize. So I can go ahead and multiply by radical 3 plus 1. A radical 3 plus 1. And now, again, I'm going to let the negative ride along here. Okay, so it's going to have to be distributed here in a little bit. But now I can just multiply this straight out. So we're going to have 3 plus 2 radical 3 plus 1. And on the bottom, it will be 3 minus 1. So from here, now we just clean it up. I'm going to do, let's see, I got 3 plus 1 is 4. With a negative, that would be negative 4 minus 2 radical 3 all over 2. And notice now I can reduce by 2. Okay, so that's going to give us negative 2 minus the radical 3. It is a much more efficient method because I have so much less to do. Okay, but again, it doesn't negate doing it using the tangent formula, but I think this is just a little bit more of an efficient route to get there rather than using the tangent formula when you've already done work for sine and cosine. Okay. All right, let's go to some other questions. Anything else from the review that we want to take a look at? 59. Okay, bear with me. Got to get back to my other page here. All right, so find the exact value of the function. So in this one, they're giving the sine of u is equal to 3 over 4. The cosine of v is negative 5 over 13. But they are also saying both of these angles are in quadrant 2. Okay? So that plays an important part here. Now, Michelle, was there a specific part of it, or do you want you just to go over the whole thing? As you write in, I'm going to state here, quadrant 2, the sign is a positive, cosine is negative, because we'll need that. Okay. I'm assuming, Michelle, you're needing the whole thing here, so I'm just going to keep moving here. Okay, so in this case, being that I'm in quadrant 2, I'm drawing triangles for each individual angle as they would be oriented in quadrant 2. Now from here, I'm going to use the Pythagorean theorem to get my missing sides. Now these were set up specifically that they would work out how to finish, or how to get, you're going to get nice answers. Okay, so I just saw your comment there, Michelle, that you just didn't see how they got their answers. So maybe all this might be is just a manipulation of their final answers. So let's see how we get there. All right, so this would tell me that you are okay, that in U, Pythagorean identity, or Pythagorean theorem would give us a negative 5. Or excuse me, that's not correct. Try that again. 16 subtract 9 is 7. This would be a negative square root of 7. Again, let's check my math again. 16 minus 9 is 7. Square root, direction of negative. Okay. Then over here for cosine of v, this one works out very well. 13 squared 169 minus 25 is 144. We'll get a positive 12. Okay. All right, so we've got those finished up. Now, as we're working through this problem, in problem number 59, they want the sine of u plus v. Okay, so in this, I've got the sine of u, but what I have to keep in mind is I'm also going to need to use and find the cosine of u. Okay, so the cosine of u we should find is negative square root of 7 over 4. And then we'll need the sine of v, which in this case will be 12 over 13. So I'm assuming that that worked out all right because we're looking at just a final answer. So we're looking at the sine of u plus v here. So that's going to be the sine of u times the cosine of v plus the cosine of u times the sine of v. All right, so getting my numbers in here. Again, I'm hoping the purple is doing okay. Red seems to be okay. If one of the colors does not do well, please just write the color and tell me not to use it, essentially. I'm going to stick with black for now until I get any responses. Okay, so the sine of u, 3 over 4. Cosine of v, negative 5 over 13. plus cosine of u negative root 7 over 4 times the sine of v, 12 over 13. Okay, now, the beautiful thing here, we're already going to have a common denominator, 4 times 13. So 4 times 13, we're looking at 4 times 10 is 40, 52. Okay, so again, might be playing with this in just a little bit here. 3 times negative 5, negative 15. The radical 7 times 12 will be a negative 7, negative 12 radical 7. Now, from here, I'm going to take a look at the answer because you said that was where your issue was here. Give me just a second, and I'll take a look at their answer for 59 as well. Okay, so here's what they're doing with the final answer. If you take a look in the numerator, 12 and 15 have a common value or a common factor of 3. But you'll notice that they're both negative. So what they're doing is they're factoring out the negative 3 from the numerator and then kind of bringing the 52 out as a denominator since it's shared. So they're essentially saying negative 3 over 52. So my 52, I don't have to worry about then behind this writing a denominator anymore because that's just being placed here. So then from here, now I'm just going to factor out a 3 from these with the negative. So 15 divided by negative 3 essentially is a positive 5. 12 divided by 3 is the 4 radical 7. So that's where they're coming up with that result. To be honest with you, if you got to this point right here, you're good because there's nothing to reduce. This is just what I think the professors, when they designed the book, would say is a housekeeping issue to try to make it look a little nicer. To be honest with you, I think this is a little easier on the eye right here. So don't worry about that too much. Hopefully you did come up with this part here. Okay, give me a thumbs up if that makes sense. And then let's go ahead and see if there's any other questions that people want to post. Excellent. Okay. All right. Let's keep the questions coming if we got them. Again, this is your time. $67. Okay. So in 67, we're trying to verify the identity, the cotangent pi over 2 minus x is equal to the tangent of x. Okay, so they're essentially using, can look at this, is that I'm assuming you're looking at the left-hand side. This is looking pretty nice. Okay, so I think we're going to work on the left-hand side here. So I think I'm going to start this way, is I'm going to look at it from the fact that cotangent of pi over 2 minus x can be written as 1 over the tangent of pi over 2 minus x. All right? Now, because of that change, what I can do here now is that I can actually, and I'm going to leave it just as the 1 over this for a moment. Okay, so now I'm going to use the sum and difference formula on the tangent, which would say in following here, I'll do this in black, that would say the tangent of pi over 2 minus the tangent of x divided by 1 plus the tangent of pi over 2 times the tangent of x. Okay, Now, because of this, and some people made this move right away, is they recognize that all you're really doing here to get rid of this is I'm going to be doing the tangent, the sum and difference formula tangent, but I'm just flipping it over. So I'm essentially able to say the following. 1 plus tangent of pi over 2 times the tangent of x divided by the tangent of pi over 2 minus the tangent of x. Okay, so it does look a little bit daunting here because we've got so much and we've got to get all the way down to tangent. But I have a feeling what's going to happen is there's going to be some things that start to fall apart here. So let's see what happens. I think I'm going to calculate the tangent of pi over 2. So that's going to be the sine of pi over 2 divided by the cosine of pi over 2. Uh-oh. Uh-oh. We should see a problem here, don't we? Okay. So maybe we need to take a look at this from a different perspective because there's an issue right here, isn't there? Cosine of pi over 2 is 0. We can't do that. So using this particular process didn't allow us, and it means that it doesn't work. So what's another option? Think about a different way of thinking of cotangent rather than 1 over tangent. How about this? The cosine of pi over 2 minus x over the sine of pi over 2 minus x. Okay? Now, if I go this route, I could technically make this a really short argument if I wanted to, using what I know about the co-function identities, that cosine of pi over 2 minus x is sine of x. This is the short way. So you could argue that the cosine of pi over 2 minus x is sine of x. The sine of pi over 2 minus x is cosine of x. Sine of x over cosine of x is the tangent of x. That would be the most efficient method of this, but some would maybe argue that that's a flawed argument because you're essentially using a cofunction identity to prove a cofunction identity. Okay? So let's say we couldn't use that method. The other option, sum and difference formulas. Cosine of pi over 2 minus x would be the cosine of pi over 2 times the cosine of x plus the sine of pi over 2 times the sine of x. All of that then divided by the sum and difference formula for sine. So in this case, the sine of pi over 2 cosine of x minus the cosine of pi over 2 times the sine of x. And now we'll start to clean up the pi over 2's. So I can make that same argument over here, that I'm going to lose all of those. So look at what you're left with. You're now left with the sine of pi over 2 times the sine of x over the sine of pi over 2 times the cosine of x, which here, sine of pi over 2, 1, either that or if you did it in this manner, you could say, hey, wait a second, those reduce. Sine over cosine, tangent of x. This would be considered probably more of the intent of that particular problem is to go that route. Okay? So again, this is one of those situations where what I tried first didn't work because it set up something inconsistent. It set up a 0 in a denominator, which we can't have. So following back to sines and cosines, whether I use the cofunction identity, the short method, which probably is not the intent, or the sum and difference formulas, we get there regardless. Okay. All right, keep them coming if we got them. $73. Gotta love the lag. All right, 73. So find all solutions to the equation on an interval from 0 to 2 pi. So in 73, we have the sine of x plus pi over 2. Yep. And we are subtracting the sine of x minus pi over 2. And they're saying that is equal to the square root of 3. Okay. So where this is going to come down to is a sum and difference formula coming out of these two. So this is going to get a little messy to begin with, and we've got to be very, very careful of our parentheses here. Okay, so I'm going to do this in two different colors. I'll do the sine of x plus pi over 2 in red. So that would be the sine of x cosine of pi over 2 plus the cosine of x sine of pi over 2. I'm going to keep that in parentheses here for now. And I'm subtracting the sign of the difference. I'll do this one in purple. So this would be the, again, I got to keep it in parentheses because that's subtraction is going to have to be distributed. So sine of x cosine of pi over 2 minus cosine of x sine of pi over 2. And all of that is equal to radical 3. Now, at this point, you really have a couple of options. You could go ahead and calculate the sine of pi over 2 and the cosine of pi over 2, and you're going to be okay. So if I do that here, just keeping something in mind, the cosine of pi over 2 being 0, I essentially lose that entire term because of the cosine of pi over 2. I can make that same argument over here, that I lose all of that. The sine of pi over 2 then is 1. Okay, so this is 1. This is 1. Oop, did I cross off the wrong ones? We're missing something here. Oh, one other thing I got to do. Easy thing to miss. Distribution of a negative. So in this case, I distribute the negative. This is now a positive cosine of x because the sine of pi over 2 is 1. Another positive cosine of x because of this one. That says we have 2 cosine of x is equal to radical 3. Okay, so it, even though it expands and looks a little daunting, these particular styles of problem fall apart very quickly and become very, very nice and compact. So now from here, the cosine of x is equal to radical 3 over 2. And since we're on the interval from 0 to 2 pi, we're now just looking at it from the unit circle. We don't have to worry about any repetition here because it's just an x. If this was a 2x, then I got to bring in repetition. Okay, so Cosine is positive, quadrant 1 and quadrant 4. We're looking at the radical 3 over 2. That's at pi over 6. And the 11 pi over 6. And that would be our final result there. All right, give me a thumbs up if that makes sense, Eposo. And then if there are other ones, anything else that anybody wants me to look at, we'll go from there. If there's not, we'll call it good for the day. $19. Okay, so we're simplifying here. All right, so this is one of these problems where I'm probably going to want to take a look at what they're leaving for an answer here, because now I don't have really a goal to get to like I do with a verification here. Okay, so I'm going to try to do this without looking at the answer, but I'm going to ask real quick, go take a look at what the answer is, and let's see how we do. Now, my goal in a simplification is really to try to make it look a little bit nicer. And so as I look at this particular problem, what sticks out to me visually is tangent of x plus 1 squared. So I think I'm going to go ahead and multiply that out because that's what I can do. That's what I can try. So when I do this, again, I'm squaring a binomial, so I don't want to just say tangent squared plus 1. I'm creating a middle term here. We've got to think about this like it's a y plus 1 that's being squared, which becomes y squared plus 2y plus 1, because I have an inner and an outer if I do consider using FOIL method here. So I get two of them that are the same. I'm going to have the same thing happening here, except it's a tangent of x rather than a y. So I'd get to say tangent squared of x plus 2 tangent of x plus 1, and all of that is being multiplied to the cosine of x. Now, I'm not going to touch this cosine of x. It can be very tempting to distribute that cosine of x in here, but I think I'm going to hold off on that for a moment because I'm seeing a Pythagorean identity. The Pythagorean identity is within this if I rewrite its order. Tangent squared of x plus 1 plus 2 tangent of x. Okay. You might recall if I group these two items here together, 1 plus tangent squared is secant squared of x. And so what this is allowing me to do then is get that simplified a little bit. But now because I have reciprocal functions here and I've got a combination here along with a cosine, this is going to be a really nice indicator. This is an indicator right off the bat that I'm probably going to want to switch to sines and cosines at some point in time to get a further reduction. So I think I'm going to do that right now. So I can write secant squared as 1 over cosine squared of x. Here I've got to be a little bit careful. When I write this, the 2, as I write tangent is sine over cosine. What I'm going to do is I'm going to take that 2 and I'm going to put that in the numerator here. So my gut instinct, without looking at this, is then what they're going to do is distribute the cosine. And when I do this, I'm going to lose one of them from here. So that's going to give me 1 over cosine of x. And then when I distribute here, I'm going to lose the cosine x on the bottom. So that's going to leave me with just 2 sine of x. Finally, what they'll probably do is take 1 over cosine and rewrite it back to a secant of x plus 2 sine of x. And that would be what my gut instinct says would be the final result here. I'm going to take a look at that real quick. We're on 19. Yep, secant of x plus 2 sine of x. Okay, so, and again, this is not the only way a person could have done it. If you changed the sines and cosines here, you would have made this work out, but it would have been a lot messier. Okay, all right, Remini, does that make sense? Let me know with a thumbs up, and then if there's other questions that are coming, let's go ahead and post them, and we'll keep going. Excellent, excellent. Okay. All right, so unless there's other questions coming, I'm going to kind of start in a little bit talking about the assessment here. What I'm going to try to do is I'm going to try to do this as close as possible to a normal assessment that you would have, but I may not be able to do it that way. I'm not sure. I'm trying the assessment thing on Schoology again, and I know that that caused some people some trouble on the lesson quiz itself, so I wanted to address that first. So you had a problem on the lesson quiz where you had to do the fill in the blank. It was the verification process. So when you clicked on that and open your window, some of you probably found that over here there was like an omega symbol. Okay, now the omega symbol is one where you could just enter a symbol, but it was very interesting. I did get a couple of emails that came back, or responses, that right next to it, which was hoping to see a pi symbol, didn't exist there. Okay, so if you are one of those that doesn't have that pi symbol, there would be another one somewhere up here that is a little box that looks like it's got a couple of mountains on it. Okay, now what this box will do is it will allow you to attach a file. Okay, so if you don't have the equation editor available to you for some reason, for whatever reason that is, then what you can do for the work that you're doing on the problem, you can attach it to a file, okay, and you can actually take a picture of your work on whatever sheet of paper you're doing it on. The only thing that I ask when you do that, make it as large as possible. Got to remember, I've got old eyes, and so it's a little harder to see them when you're kind of away from it. So if you can zoom in as close as you can, that is an acceptable way to turn in those kinds of work problems. Now, for those who do have this symbol, okay, if you do have the equation editor, how this works to help you through a little bit is that in the equation editor, when you click on that button or click on that link right here, what it does is it opens a separate window, okay, a little bit smaller. But then what you'll see across the top up here is you'll see a whole bunch of different little things. And so in one of those, it's going to talk about functions. So if you click on each one of those, okay, if you click on each one of those, what you will find is in there, it's like the second or third little, they've got like little breakdowns. It's like the second or third one over here that's going to deal with functions. Okay, now it won't say functions, but you'll click on it and it'll show different things. But when you open that up or click on it, you're going to find in there is that you'll see lots of different things. You'll see it'll look like a square root that'll be written like this, or it might have a little box. I think it says something like that, and then it might say something like that. Okay, now this is in that equation editor, but over to the left of that, there will be what looks like something like this. Okay, so it does have a fraction ability to it, and so when you click on that, what it'll do is it'll open a little window, kind of like how it does on your iPad calculator. And so then you can go ahead and you can click into these little spots and you can type in your function as needed. Now, in that equation editor, you'll also have all of the symbols that you can use, the Greek symbols like alpha, beta, and whatnot. I'm not going to worry about that too much. I will try to use theta for the most part, but if we do have anything else, I'll probably use alpha and beta, so they're totally different. A and B gets kind of hard because what'll happen is once you finish this, you have to close it, and then it brings it up into here. Okay, so this window then brings it up in here. So then if you have to do a second line, then you just click this again, and then it'll give you another one of these windows to do the next line down. Now, in the assessment program that I'm trying to use on this, I don't know if it's the same. So I'm going to be working on that over the weekend here for the assessment, and then but then as soon as that session is done, we'll open the test up so that you can get it taken. Okay, so hopefully you can make sure that Monday is free for the most part to try to get that taken care of. I know that you'll have other classes that are starting to come online, so I do recognize there might be some time constraints that are starting to happen for you. And that's one of the things that I think we as a building have to figure out, how are we going to balance that for you. So stay tuned for potential changes, even with the time that we meet here. So, all right, so from here, just a real quick coverage on what we're looking at for the quiz or for the test. Sorry, I can't show you the key. I left those at school, so I have to retake all my tests. So you're going to be doing, the first learning target is about simplifying trig expressions along with verifying trig identities using some algebraic method in that. So that's pretty much the beginning of the unit. Then the second learning target, and again, I'm going to have to adjust maybe the numbers of problems on things. Right now I've got it set for there to be 1, 2, 3, 4, 5, 6 problems. But again, I might play with that a little bit just so that we can kind of condense this down, because it's all new to everybody. And I don't want you to feel overwhelmed with it. So I'm going to do everything I can to try to make it as simple as possible for you. Okay. Then the second learning target is solving trig equations with application problems, again, using various techniques, including the use of identities and strategies. Okay. So I'll give a little bit more information on that when we come back on Monday. Again, we're hoping to meet at 9. Again, if I get some other information through the day, I will definitely make sure to update you. So at this point in time, we'll call that good. But I'm going to do one other thing here real quick for you. Okay, so for those of you that are in the room, okay, I definitely want to thank you for coming. I'm hoping that you found this to be beneficial. We're going to keep it going. But one thing that always gets to be kind of hard, especially if there's, like, let's say there's an issue on on a quiz. Like if I've got a problem that is incorrect for some reason that I made a mistake, I want you to be able to let me know pretty quickly. Okay, so here's what I'm going to ask you all to do. I know I might have a couple of these, but I'm going to give you my cell number. Okay. Now, purpose of this is so that if you have an individual question or something, you can contact me directly. If you would please, I want you to send me a text and just put your name with it, and then I'll put that in my contacts so that I know who I'm talking with when you come in. Otherwise, people would come in and I'd be getting all these texts coming in and I don't know who I'm talking to. So if you can do that immediately after we're done here, just send me a quick text, give me your name, I'll get it in a contact, we're ready to go. Okay. All right, final call. If we're good, give me a smiley face emoji if you're good. Smiley face emoji, that'll be your way of saying, okay, have a great day, Mr. Vaerst, and then we will see you all on Monday. So I get 2 days off. The lag is fun. Ah, somebody got creative. All right, there's my first text message. Awesome job. I don't know who it is, but I'll find it in just a second. Okay, it looks like everybody's doing okay. I'm not getting any more coming in. All right, we're going to call it good, everybody. So have a great weekend. Get outside a little bit today, even though it's windy. Get outside. Do some exercise because being inside all day, pain in the butt. So get out there. Enjoy a little bit of this weather. It's supposed to get a little bit quicker, a little bit nicer here coming. Go do something fun. Get outside. Walk around, whatever it is. Have a great weekend, everybody. I'll see you back here on Monday at 9. Thanks for coming, everybody. Take care.